This is the homework review for 12-2. You will pause the video at different places where you need to calculate or try something after looking at a setup. So your assignment from 12-2 was listed 1 to 4, 6 to 8, 10 to 14. And as you complete the exercises, you want to be sure that you're using the correct trig ratio, and you want to be sure that then you're getting correct values from your calculator. So for 1 and 2, I'm showing my setups, my initial trig ratios based on SOHCAHTOA for the picture available. If you need to, for each one, go back and actually see for the right triangle what the names of the sides are that are involved in making the two parts involved in the right triangle. So, oops, and I labeled that one wrong. Can't talk and write at the same time, apparently. So from the 32-degree angle, that would be hypotenuse, and the side A over here would be opposite, which is why I chose sine as my ratio to involve those two if my reference angle here at 32 degrees, where I'm checking everything from. In number 2, my reference angle here at x, then I have my opposite as 18 and my hypotenuse is 20, which is why sine was chosen. And then they did suggest that you round to the nearest whole unit, or they did say to do that. On the next two, as we go to set these up, again, my goal would be to find the information required, but first it might require me to find a different value. So on number 3, for instance, I'm really going to have to find the diameter because the triangle is a right triangle. Little exam review. If this is a diameter, then 180 degrees of arc, the inscribed angle would be half that, or 90 degrees. So from the 32-degree reference angle then, I'd be looking at an adjacent side of 12 and a hypotenuse that's really the diameter. So I would set mine up to be my cosine ratio, because it's using adjacent and hypotenuse. Cosine from 32 degrees would be my adjacent over, in this case you could put d, I'm going to put 2r. So 2 times my radius times cosine of 32 degrees would be 12. So my radius would be 12 divided by the product 2 cosine of 32 degrees. Make sure when you do this on your calculator that that entire denominator is what you divide by, and therefore your radius comes out approximately 7. In number 4, we can move that altitude that E is representing. We can just slide it over between the parallel lines, and now we have a right triangle. We are looking at knowing the opposite length and being interested in not the opposite length, knowing the hypotenuse and being interested in that opposite length. So I'd use a sine ratio from that 62-degree angle. Would be my opposite, which is E, compared to my hypotenuse, which is 27. So to get that E length before I go to a calculator, because we don't want to write down any of those trig ratios, we already did by saying sine of 62 degrees. Then getting a calculator approximate and rounding. But you're noticing I never write down the approximate value of that trig ratio that I see on my screen. Number 6 and number 7, same idea. In number 6, we have an isosceles right triangle. So we do know that the angle F they're seeking is also repeated as the other base angle. We do know that because those are the base angles, that the opposite, or that the base side gets split into 2 equal parts. So as we are looking for angle F, I have a tangent ratio. I have my opposite and my adjacent legs of that right triangle. So the tangent from F would be 16 over 14. So as we're looking for angle F, we need an inverse relationship. We need to invert the equation by putting in the input as the output. So I want inverse tangent of, please make sure you're setting up your inverse statements correctly, so model them after ones you've seen. Then I'm ready to go to my calculator and find out what size angle measurement that is within to the nearest whole unit. We get to number 7. Number 7, they're interested in that theta, that angle outside the right triangle. So at the moment, I'm going to have to do a little different angle and find that one, because within the right triangle, that's all my right triangle trig can help me find. Within that right triangle, then, tangent from my angle marked x would be 16/12. Then as I go to find x, I will need to do the inverse tangent of 16/12. That isn't going to get me the actual 127-degree angle. As I'm working with that one's going to get me, and the number on your screen is going to be about 53.13. So the angle that I'm missing here around. And again, letting that stay exact on your screen, my theta then is 180 minus my x. And that's where we come in at around 127 degrees. Number 8, In number 8 setup, it's a lot like that super diagonal that we were working on with Pythagorean theorem problems. Before I'm going to be able to find angle beta, that capital looking B value, I need to find one more side on that triangle. So on the bottom face of that block, I went and found the diagonal across the bottom face, which is 17. Then I could go ahead and inside the right triangle, whose side lengths are now 10 and 17, I am seeking angle beta, which would be as marked. From that, I have my opposite and adjacent legs to set up a tangent ratio and calculate from there. Again, remember, stop this video wherever you need to. The word problems. This setup is the hardest part. So people often say, well, if you just give me the picture, I can do this. Well, the trig is actually what you're using it for, but the setup is the reasoning and the rationale. Can I make an accurate picture so that I can see the trig necessary to calculate this? So the 800 meters of string, when you imagine holding a kite, is from where you're standing at a diagonal to the earth. It's not at a horizontal or vertical, so that string is let out, so at the end of the kite. Once I have the picture in place, then doing the trig I can go ahead and work with. So mine's going to be a cosine ratio because I have the adjacent that I'm interested in and I have the hypotenuse side. So there would be my trig setup. And then show your cross product so that we actually understand how you went from that to your value for D. And again, rounding here, it's around 655 meters, a little over half a kilometer. In number 11, there's another kite, except this time we know how the distance between the two friends on level ground, and when we know the angle of elevation that the string makes with a horizontal. So how high is Benny's kite is illustrated. From this one, we can see we'd need a tangent ratio. Tangent ratio from 39 degrees would be opposite over adjacent. So our height's going to be 125 multiplied by tangent of 39 degrees. And again, with some practical rounding. Number 12, they gave you the picture, so I would just go straight to trig setup from here. Tangent from 33 degrees will be 42 over y. Again, because a proportion means that these two are actually swappable by algebra, we could demonstrate that as we have in class. I can get to y as 42 divided by tangent of 33 and get to my value. 13. When you draw the picture, you have to make sure that you're understanding where that angle of depression goes, and the most common incorrect place is to put it here. And if you put it there, we end up having something that's not the true angle of depression. So angles of depression are always between a horizontal and a line of sight upwards or downwards. So they always have to have a horizontal as one side of that angle. So as they describe it, I'm thinking of the ship on wherever this top surface of the water is, that's my horizontal, and a 12-degree angle of depression is where that salvage or wreckage is located that they would like to salvage. I suppose it's wreckage, and they're doing the salvaging. So as they see that, they're going to drop a diver at an altitude, if you want to think about that, at a right angle from the surface to the bottom floor. You can see that marked in my diagram. So that 12-degree angle is not on the right triangle picture, but we also can do this several ways. So if we wanted to, we could also put our 40-meter side here. The other place we could put our understanding would be that this alternate interior angle here is also 12 degrees. Either way, you end up with a right triangle, which from 12 degrees, we're interested in the tangent ratio. So the tangent ratio from the 12-degree angle would be 40 over our D value. With D and tangent of 12 being interchangeable because of your cross product relationship, we can get to here, and then we can get to that 144 meters. Number 14, unfortunately, because of the way it comes in the lineup, sometimes people misunderstand and think they're looking at this from above, and they aren't. They're actually on the ship. You are the ship's officer, and at one point you have to understand where the path of the ship is. So I've got my path heading in a horizontal, meaning the line that the ship is actually trying to follow. The ship's officer sights the lighthouse at a 42-degree angle to its path. So path to lighthouse, 42 degrees at its first location. The ship continues on its path. It does not change course, and it stops. And when it stops, it's at a 90-degree angle from the lighthouse to the ship's path. And the information that they give us is that it has traveled 1,800 meters in that time, and therefore they are looking for the distance it is at the second sighting to get to the lighthouse. So from here, and again, spend time on the setup, that is the hardest part. Here we're looking at a tangent ratio from 42 degrees of d over 1800 meters. So then our distance is 1800 meters multiplied by that tangent ratio value from 42, and there it is. Okay, any of these that you need to, go back in the video, pause the video, and use it to help you understand the problem better.